So in any right triangle with a 40-degree angle, the side opposite that 40-degree angle is always going to be roughly 64.28% of the hypotenuse. Doesn't matter how big or how small that triangle actually is, this will always be the case. And this is what is meant by the sine ratio within the context of a right triangle. When we take the sine, cosine, or tangent ratio of an acute angle in a right triangle, what we're actually doing is comparing the length of one side to another. For cosine, we're comparing how long the adjacent leg is when compared with the hypotenuse. Look at that, 76.6%. So in any right triangle with a 40-degree angle, no matter how big, look at that, or how small, that adjacent leg is always going to be roughly 77% of the hypotenuse. And now for tangent, look at this. Tangent compares the length of the opposite leg to the length of the adjacent leg. And would you look at this right here? Gosh, it almost takes 100% up, doesn't it? Right? That's roughly 84%. But I wonder, what angle would actually make the opposite leg equal the adjacent leg? Wouldn't it be 45 degrees? 3, 4, 5. Ooh, look at that. How cool, right? And for a triangle with a 30-degree angle, let's see, 30 degrees. If we take the sine of 30 degrees, notice here, the opposite leg is always half of the hypotenuse. So we get that 50% right there. So again, this right triangle here is similar to every other right triangle I'm making because of the angle-angle similarity theorem. So that's why these trig ratios hold true. That's why the trig ratio for any acute angle within a right triangle always remains constant. So in any right triangle,